Hello, this is Miss Williams, and we are in Accelerated Algebra 2 with Topic 6, Lesson 3, Logarithms. Today we'll be able to evaluate and simplify logarithms. We have 4 vocab today, so make sure you have your vocab sheets out ready to go. Okay, so here is our kind of warm-up. We have earthquakes make seismic waves through the ground. The equation y equals 10 to the x relates to the height or amplitude on a seismograph. And y is the power or magnitude. X is the ground shaking it, what it can cause. Okay, so what is the magnitude of an earthquake with amplitude 100,000, and how would you know? Okay, and so first off, I want you to think about if this is your equation. Right, how can we get amplitude, which is your y? What could you do to be able to figure this out? Okay, go ahead, pause the video and see if you could also find the exact magnitude. Okay, as you are working on this, right, you should have gotten x equals 5. Now, working on this, there's a couple of different ways to do it, okay? But how could we get that? Might have to deal with, we could work with same bases we've talked about. Okay, getting this in a base 10, which would be 10 to the 1, 2, 3, 4, 5, and such that x would equal 5. Okay, now if I wanted to find this, what would be the magnitude that would have given me the 5500 amplitude? Do we have a way to get that if this is not capable of being base 10? Okay, so with that, that's what we're learning today, is how can we undo, right? How do I get this x out of the exponent? Okay, and that's what we're going to introduce today. So what are logarithms and how are they evaluated? In our vocab, you're going to be writing down our vocab words of logarithm. Has a base b of x, is defined as the following. So you will read this as log base b of x equals y. If and only if that this is the same as b raised to the y equals x. So first we're going to just work on, I want you to write these down in your vocab sheet. Then we're going to write them in your notes. And then the logarithmic function is just y equals log base b of x, is by definition the inverse of the exponential function. This is a key one. I would highlight that one for your hint on what you could be tested on. Okay, so in your notes, what I want you to write is this. So on your side notes, I want you to write log, and you're going to write log base b of x equals y. This x is kind of in parentheses if you think of it that way. This is the same as, we're going to be able to go back and forth. So when I say log base b, b is my base, my bottom. I'm going to raise it to the y, and that is going to equal my x. Okay, so it's like a little cycle on this. Same if I was going backwards, I would just write log base b of x equals y. Okay, so if I was given this, I would write log, and I would start with base b is the bottom, base is the bottom, to the x, just in my little cycle, equals my y. The main thing that you can remember is that logs equal the exponent. That's what a log does. So when you're talking about a log, the answer is actually the exponent in it. Okay? So first example. We're going to look to write this in log form. Okay, so with this, right, if we were to solve this, you might know this, right? 2 raised to what gives you 8. Okay, and so with this, right, we might be able to go, okay, this translated, so let's try to translate this into log form. We got log, this is my base, so little 2 to the 8th equals my x. Okay, now this is what we would solve this as. So right now that would be our answer. We don't know how to type that in yet, but in your case, solve 2 raised to the x equals 8. What we would try to do is get our bases to be the same. So 8 can be rewritten as 2 to the 3rd power, such that then if I have the same base, x equals 3, because then same base, then my exponents must also be equal. Okay, so right now we're just going to work on practicing going back and forth between the forms. Okay, so we are going to write in logarithmic form of y equals 8 to the x. So we have log base is the big number 8 to the y, so that's going to be on the same side, and then when you go over the equal sign, logs, remember, equal the exponent. Okay. Alright, we already did 2, so why don't you do 3? Pause the video if you need. Go ahead. Alright, let's see how you did. You got log base 1/2 to the y equals x. So we should see a pattern here of my exponent is always what I equal. That is what a log equals. Okay, so exponential form shows that a base is raised to an exponent equals the result. Okay, so we have to be able to go back and forth. Here's just a way to show where my letters go. Okay, so we have our exponent is what our logs equal. We have our base goes to the bottom, which is our a, and then we have our result in exponential form, which goes in parentheses with the log. Okay, so you have to know the difference between here is exponential form when we have the exponent. Logarithmic form has the log involved, meaning that we have the log. Okay, so we're going back and forth between the two. Okay, so we're going to convert to what is the log form. So now we're going in reverse. I'm going to immediately write log base. Think bottom is the big number, so 3. I'm going to make my little cycle to the 81, and that's going to equal my exponent of 4. Okay, I want you to go ahead and write in exponential form what would log base 10 of 1,000 equal 3 give you. Okay, and you should have gotten 10 raised to the third, because that's my exponent, equals my 1,000. Now, in these first ones, that should make sense, right? 10 cubed is 1,000. Okay, so go ahead. You can use a whiteboard marker if you want, or just write in your notes. Go ahead and pause the video to be able to do 2A and 2B. Alright, let's see how you did. Log form should be log base 7 of 343 equals the exponent of 3. We should have 4 squared equals 16. So this one should make sense, right? We shouldn't have had any other combination, because otherwise we would have known it wouldn't equal each other. Okay. Next, we're going to actually find the value, because these actually do have a value. Even though there's no x in any of these, they all have some kind of value, right? This is just like saying, this is a fancy way might be saying of 3. Okay, even though right now I don't even see a 3 in it. It's just a different way to write it. No different than I can write 9 is the same as 3 squared is the same as 27 divided by 3, right? Those are all 3 different ways to write 9, even though the other 2 don't have 9 in them. So when we're simplifying, what is the easiest is just to set this equal to x to actually make it. Now we're trying to find our value here, and so now I'm going to change forms, right? So I'm in log form. If I'm in log form, then I'm going into exponential form. So I'm going to start with 5 raised to what power of x gives me 125. Okay, now some of you might need to use your calculator on this, but if I wanted to, I should know that 125 is 5 cubed. And so now I got same base, my exponents equal, so I get 3. So log base 5 of 125 is really just 3. Okay. In this one then we're going to set it equal to x. Okay, we're going to manipulate this. We're going to start by putting this in exponential form. So again, we have 1/4 raised to the x equals 16. Now, right now we are trying to get these to be the same base. We had been working on that. So what I'm going to do is bring my 4 up, which means then I'm going to have a negative x. Okay, because this is really 4 to the negative first times x. Okay, now how do I rewrite 16 as a base 4? Well, 16 is 4 squared. I got my same base. I'm going to set my negative x equal to 2, and I get that x is negative 2. Alright, let's try this one. So we're going to set this equal to 0. Go ahead, change that into exponential form. Okay, and you should get 3 raised to the x equals 0. Now, I want you to think about what, now this is not, we can't make 0, 3 as a base. So what, when I raise it to 3 raised to what power would ever give me 0? And if you think it's 0, well, let's try it in your calculator. Type in 3 raised to the 0 power, and you should get 1. So there is no numbers that can make this happen, so this is a no solution. So logs cannot go below 0, or cannot be equal to 0. Okay, let's see this one. Go ahead, change this one to exponential form. And you should get 2 raised to the x is equal to 2 raised to the 8th. Well, we got same base. We got x equals 8. Okay, so there's 2 things that kind of came about these 4 examples. 1, this can never be 0, or you're not going to have a solution. 2, if your base is the same as this, they really just cancel out, giving you your exponent of 8. Okay. So I want you to go ahead and try these on your own. Pause the video. Okay, let's see how you did. We have 3 raised to the 1 over 81. Okay, remember I said we wanted to try to make these the same base, and so 3 to the x 1 over 81 is really 3 to the 4th. And I want this on top, so in order to bring this on top, I'm going to make my exponent negative, resulting that they would be equal, and x equals -4. Okay, in this one we got 7 raised to the x is equal to -7. Well, 7 raised to any exponent is going to be positive, so we will never be able to get a negative number, and so this is no solution. Okay, in this one we should have gotten 5 raised to the x equals 5 to the 9th, which gives you 9. Okay. Our next 2 vocab words are, we have, what happens when we have a base 10? That is called the common log. Okay, it is written as just log base x with the base 10 implied. So this, when it's not written, really means this. Okay, it's that invisible 10 there, no different when we write a square root, and we should know that this is a 2. Or when I raise x, this is really x to the 1st. Okay, and so this is what is in our calculator. So when I calculate a log, it is always base 10. What we also have is called the base E logarithm, which is called the natural logarithm, which is also known as the ln of x. Okay, so same thing, if I write the ln of x, that is really like saying the ln base E of x, which the same rules apply. Okay, when this goes, I can still do my little cycle. Okay. The other thing I want you to know, so we're going to have, I want you to write this down in your notes, is that the log base E is equal to the ln. So anytime you have log base E, when we're switching back and forth, that is the natural log. Okay, if you see the ln of 4, that's really like saying the ln base E of 4. Okay. Alright, we're going to work on some then of this. So first off, we're going to just type this in. We're going to learn where these are on our calculator. Okay, you should have a log button. This is the common log. So I'm going to type in log, And I'm just going to type in the argument of 900. And we are going to round this to the nearest thousandth, so 3 decimal places, which gives us an approximation of 2.954. Okay, now where is our ln button? Is down here. So it's right below the log. We're going to hit ln, and I want to find e. This is just e to the first. So remember I taught we have 2 places where e is. I can go second, and mine in this case is above my division. And so I can hit that. That is just e to the first. Okay, I'm going to hit enter, and I should get 1. My other option is to hit ln, and I'm going to go second ln. So that same button. And now it says arrow up. Well, I just want it to the first power, and I should still get 1. Okay, you guys go ahead and try and type in C. And you should have gotten an error. Okay, so in this one, this is your no solution. We cannot have a negative number. We cannot go below 0. Okay. And so where is that going to help us? Is that's going to help us solve our equations. Okay. So this is going to be, this could be in our calculator, or it all depends on what we have. And so you have to know that anytime you have an ln or a log base 10, these are in your calculator. But if you have a log base anything else, you cannot type that in your calculator. We're going to have to learn a new way to find that. Okay, so what is the solution to the equation? Here's my hint. Anytime that x is in the exponent, we need to convert to log form. Why? Because logs are equal to the exponents. That's the only way you can bring your exponent down. And so so if I'm an exponential, I can't solve this, then I'm going to switch forms. So anytime you can't solve it, you're looking to switch forms. So I'm going to switch this to log base 10 of my 25 is going to equal my exponent of x minus 1. So here's my exponent. Logs is the exponent. Okay. Now remembering that log base 10, this I can type in the calculator, which is exactly what we're going to do. Okay, we're going to get a value, but first I'm going to actually solve this by adding the 1 over. So we're going to write 1 plus log 25 into our calculator. Okay, so I'm going to go 1 plus log of 25, and I should get approximately 2.398 for x. So in your calculator, it's going to look like 1 plus log 25. Okay. All right. Next one. Okay, second one is then we have the ln. Okay, the key here is that you know that the ln is really the ln base e. And so we're going to switch forms, meaning I'm going to go from log to exponential. So here's I'm going to put my e in here. And so we really have e raised to the 4th equals my argument of 2x plus 3. Okay, so now this is, remember, e to a number is in your calculator. That's another number. Okay, so we're going to solve this by just subtracting 3 and we're going to divide by 2. Now you can type that all in your calculator, or you can hit enter. I usually go second e, and I'll go e to the 4th. Close your parenthesis. I'm going to minus 3, and I'm going to hit enter, and then I'm going to hit divided by 2, and I should get 25.799. Now I want everyone to type that in because there's a lot of things that could go wrong on here. I'm going to show it on my other calculator as well. And so we would type in second e, and I'm going to go to the 4th, and I'm going to arrow down so I get out of the exponent, minus 3. Now notice how I have not put this as a fraction, so that's why I'm going to hit enter and then divide by 2. Otherwise you are only going to divide 3 by 2 and not get the right answer. Okay, if you need to pause and help each other out on that, do so. Okay. Alright, then last two. I want you to pause the video and see if you can solve these. Alright, let's see how you did. Log, this is a base 10. Okay, so if you weren't sure, that was log base 10. I wanted you to try these, so we should have 10 raised to the second is going to equal this 3x minus 2. Well, 10 to the second is 100, and now it becomes back to algebra 1 where I'm going to add 2, divide by 3, and we get x to equal 34. Okay, on here, now this one I understand if you didn't quite remember. So if I want x is in the exponent, right? So I need to change forms, which what has a base e. So if I wanted to, I could go log base e of 8 equals this x plus 2. But remembering, what is log base e? That is really just the natural log of 8. And then I got x plus 2, so I'm just going to subtract 2. And so when you type it in, make sure you close your parenthesis on that, and you should get x to be about 0.079. Okay, keeping it rounded to the nearest thousandth. Okay. So, recap. All right, log base 10. When there's nothing written there, okay, anything with base e, so we have the ln is base e, and so that's how we're going to go back and forth between those two. Okay, so that concludes the lesson. We have our homework for T6 L3, and that is on page 307. We got 13 through 16 all, 19, 20, we have 24, 28 through 32 even, 36, 40, 42, 46 through 52 even, 53, and 57. Okay, this is a lot of practice of just back and forth. That's why there's a lot of examples. And so a lot of them should go quick if you know how to. We're just going back and forth. A lot of the beginning ones are not solving for anything, just practicing but going between the forms. All right, thank you.